What we want to do here is determine the x-intercepts, or the roots, or the zeros, whatever you want to call them, of the following functions. So what we have in front of us are four quadratic functions given to us in factored form. Now I'm going to go over in detail how to extract the roots and what it means for the first one. And then the other ones, you'll see that there's actually a pattern, a very simple pattern in determining the roots when the function is in factored form. And that is if indeed it can be expressed in factored form, because that's not always the case. So the roots are when the y value equals 0. So a root is when y equals 0. So in this case, I'm going to set 0 on my left-hand side and recopy the expression here. So x minus 1 and then x plus 4. Now this is a product. In between here, the operation is multiplication. So if the product of two numbers is 0, then the only way that can happen is that one of them is 0. Let's take an aside here. If I have 2 times something equal to 0, well, that something, the only possible number it can be is 0 itself. So that same logic applies over here. Either, now in this case, I don't know what the numbers are, so either x minus 1 is 0 or x plus 4 is 0. So let's start with the first one. If x minus 1 equals 0, well, if I solve this equation, that means x equals 1, and that's our first root. On the other hand, if x plus 4 equals 0, I bring the 4 over, and this becomes x equals negative 4, and that is our other root. So the roots of this equation are 1 and negative 4. And you can see that if I take, for example, the 1, and let me just erase this. If I take this 1, let's actually pick it up here, and I put it over here, and I place it over here as well. Notice that this factor here becomes, well, 1 minus 1 is 0. And 0 times whatever this number is, I don't even care. I know it's 5, but it could be a million trillion. I'm still going to get a product of 0. And the same thing works if I applied the negative 4. So that's the long way of determining the roots, but if you were paying attention closely, you'll notice that if I look at the original question, and I look at the numbers that are in each bracket, my first root, well, is the opposite of negative 1, which is just 1 over here. My second root, the opposite of positive 4, negative 4, which is just over here. So technically, I don't have to go through all this work. This is the detail as to why these are the roots. But all I have to do is go to my equation and just read them right off. So I can just say 1 and negative 4. And in fact, we're going to do that with the next one. So over here with b, again, I'm going to skip all that calculation over there, and the opposite of positive 8, well, my first root is going to be negative 8. My second root is going to be positive 2. Moving on. Over here in C, same thing. The opposite of negative 5, and who cares what this guy in front is? It could be anything. Opposite of negative 5 is 5. The opposite of positive 2 is negative 2. Now the last one doesn't look like it follows the format we had before, because the previous ones were, you had y equals, I don't know, something, and then we had 2 sets of brackets. Now this one only has 1, so like, what's the deal here? Well, we have to look closely at what is being expressed in this equation. This factor here, let me write it maybe in a recognizable way for you, and then you could probably think or figure out what the root's going to be. What if I subtracted 0 or added 0? I don't care. Subtract, add, makes no difference. Now does it look familiar? I think so. The opposite of negative 0, which, 0 positive negative is the same number, is just 0. And that's our first root. So it's kind of hidden in there, but the root in this case is going to be 0. And the second root, well, that's an easy one, is just going to be 8. So anytime you see an x multiplied by a binomial or anything, you know that one of the roots is going to be 0, again, provided that it is in factored form. So there you have 4 examples where we list the roots for you just by pretty much reading them off the equation itself.